Exercise 4G, question number 10. Three events A, B, and C are such that probability of A is 0.4, probability of B is 0.7, probability of C is 0.4, and probability of A intersection B is 0.3. A and C are mutually exclusive, and B and C are independent events. Using this information, let's draw the Venn diagram. We have three sets, A, B, and C, and A and C are mutually exclusive. So if A and C are mutually exclusive, which means the two sets do not intersect. This is A and this is C. So A and C mutually exclusive. B and C are independent. So let's draw the circle B. This is our B. Okay, now it's given that B and C are independent events. Now when events are independent, in this case probability of B multiplied by probability of C is going to be equal to probability of B intersection C. This is because B and C are independent event. We have probability of B as 0.7 and probability of C as 0.4. So probability of B 0.7, probability of C 0.4, and that is equal to 0.28. So with this we have found the intersection of B and C, which is 0.28. Let's write the value 0.28. It's also given in the question that probability of A intersection B is 0.3. So we can fill up that 0.3. Now we know that probability of A is 0.4. Therefore the entire circle of A is 0.4. So if this part is 0.3, only A part will be 0.4 minus 0.3. That's 0.1. Then we are given that probability of C is 0.4. Therefore, this entire circle is 0.4. From 0.4, we'll subtract 0.28 and we get only C, which is 0.12. Again, we have probability of B as 0.7, which is this entire circle. We need to find this part, which is only B part. So from 0.7, we can subtract 0.3 and 0.28, and that gives us 0.12. Now we can find the probability outside the three sets A, B, and C. We know that the total probability in a Venn diagram adds to 1. Therefore, by subtracting the known probabilities from 1, known probabilities are 0.1, 0.3, 0.12, 0.28, and 0.12. We subtract all of this from 1 and we get the answer as 0.08. So the probability outside the three sets is 0.08. Now, the first part was to answer probability of B intersection C, which we have already answered here. B intersection C is 0.28. Second part, part B, is the probability of B given that C. Probability of B given that C means we need to look at only the circle C. So that's our total. From the total, we need to find the probability of B. So B part is only 0.28. So the probability of B given that C is 0.28 divided by all of C, all of the probability of C, which is 0.4, and that is 0.7. That answers B. Moving on to C. In part C, we need to answer probability of A given B complement. So in this part, this is again a conditional probability. Our total is B complement, from which we need to find the probability of picking A. B complement means everything outside the circle B or everything excluding B. So that is 0.1, 0.12, 0.08. This is our total from which we need to pick up the probability of A, which is 0.1 divided by the total. So that's going to be 0.1 divided by all of the B complement that we just saw, which is 0.1 plus 0.12 plus 0.08. And that is equal to 0.1 divided by 0.3 or 1 by 3. That answers part C. Moving on to part D. So in part D, we need to find probability of B intersection C given that A complement. So given A complement means we are looking at everything outside A, or we are looking at everything but A. So everything outside A is 0.12, 0.28, 0.12 and 0.08. Now from this, we need to find the probability of B intersection C. B intersection C is this part here. So from the total of 0.12, 0.28, 0.12 and 0.08, we need to find the probability of 0.28. So that is going to be our D. So that is 0.28 divided by 0.12 plus 0.28 plus 0.12 again and plus 0.08. When we simplify this, we get 7 over 15, which is 0.46. Also, we can note that for conditional probability, we can write the formula. For example, for this one, B given that C is probability of B intersection C divided by probability of C. And likewise for part C, it would be probability of A intersection B complement divided by B complement. And for part D, it would be B intersection C intersection A complement. I'll write it here. For part D, it will be probability of B intersection C intersection A complement divided by A complement, which leads us to the same result as we have.